Well, heroes, it's time for us to move on to thinking about percents. And so the purpose of this video is for you to be able to take some notes to review the things we learned about finding percents or finding wholes or finding parts of wholes last year, and also to be able to apply that to this idea of percent change, which sometimes is often discussed in the sense of adding tip, adding tax, or even taking away money or percent of the price if something was on a sale or as a discount. So I'm going to first start by saying that percent is, as you recall, hopefully always out of 100. So per is per cent. Think about how many cents are in a dollar. There are 100 cents in a dollar. So the ratio or the proportion that we were setting up last year was this idea about finding part over whole is equal to percent over 100. Or you can think about it as being is over of equals percent over 100. And so once you read the information from the word sentence, you can set up your known and your unknown ratios and set them equal to one another. And then your only job is to solve for the missing value and answer the question. So I would suggest that you write down these 3 problems as I go through them as just reminders of really what we're trying to solve or what we're looking for here. So in number 1, or the first one rather, it says what is 60% of 28? So in this problem we know that we are finding the part because we don't know what number is 60% of 28. So let's write that down on our notes. That should be big enough. So that means that we're going to say is over of equals percent over 100. And then if we set up our proportion, I don't know the is, so that's going to be my x, of 28, 60%, and then the 100 is always there. And then we've done a lot of problems like this recently where we can just cross multiply and then divide. So here we have 28 times 60 is equal to 100 times x. 28 times 60 is 1,680 is equal to 100x. Divide both sides by 100 so that we isolate our variable, and that's going to give us 16 and 8/10 is equal to x. This tells me that 16 and 8/10 is 60% of the number 28. In the next problem, it says 74 is what percent of 115? So if we look at this problem, it says 74 is. We're looking for the percent, and that's out of 115. So if we set this problem up, we're going to find that we need to have the same idea, is over of equals percent out of 100. 74 is, I don't know the percent, I know that percent is always out of 100, and this is the of 115, so 115 is going to be my whole there. Again, I can cross multiply and divide, so I'm going to end up with 115 times x equals 74 times 100. 74 times 100 is 7,400 is equal to 115 times x. Divide both sides by 115, and my x is going to give me 64 and 347 hundredths percent. Okay, so we're going to round to the nearest hundredths place, which means I'll take and see that this 7 is greater than 5. So I'm going to round this number to 64 and 35 hundredths percent. So I would be able to answer this question by saying 74 is 64 and 35 hundredths percent of 115. The last problem on this page says 36 is 45% of what number? So I'm looking here and I see 36 is, so that's clearly my part. And I also notice that I'm being told 45%, but I don't know the whole or my of. So as I start to set this problem up, I'm going to use that same setup, is over of equals percent out of 100. So I'm going to set this up using 36 as my is. I don't know the whole or the of is equal to 45% out of 100. I'm going to solve this the same way I've solved the others, cross multiplication and division. So I end up with 45 times x is equal to 36 times 100. So 45x is equal to 3,600. I want to divide both sides by 45 to isolate my variable, and x is going to become 80. So I don't have 80% as an answer. I now know that 36 is 45% of the number 80 because I've just solved for the whole. So as we move forward, we're going to think about percent change. And percent change can be the idea of an increase, which is often in finding the tax, the tip, calculating interest, or a change in value, considering this idea of like new versus old. It can also be a decrease, where we're talking about a discount or a change in value, a new price compared to an old price, or something along those lines. So let's look at one together. Will and his friend went out to lunch. They spent $24.50 on lunch before the 8% restaurant tax was added. How much tax will be added to the bill? So there's a lot of words here that just tell us about this scenario, and they're not necessarily helpful for us for solving a problem. So in keeping the idea that we want to figure out the tax, I'm going to read these words carefully, and I'm going to notice that it says they spent $24.50 as the total for lunch, and then they have to add 8% restaurant tax. So I really want to know what is, oh, there's that silly highlighter. What is 8% of $24.50? And so if you were paying attention on the first couple of slides, we've already solved problems like this. So now we've just taken our simple word sentence and put it into the context of a scenario or a situation that's more real life. So now that I know that I want to find out the answer for what is 8% of $24.50, I can easily set up my proportion is over of equals percent out of 100, meaning I don't know what that amount is, but I spent, or Will and his friend spent $24.50 at lunch, and they need to pay an 8% tax. Once we have this set up, we should go ahead and be able to do the same process of cross multiplication and division. And so when you do that, we get that $24.50 times 8 gives us 196 is equal to 100x. So from there I can just divide both sides by 100, and I find out that x is $1.96. This tells me that Will and his friend will have $1.96 added to their lunch bill for tax. So this slide says the same thing. I'm just going to go ahead and fill in that they have to pay or add $1.96 in restaurant tax. So it says the friends also choose to leave an 18% tip for the waiter. How much will the friends leave for a tip? So this is where we have to make a decision as to whether or not Will and his friend are going to tip prior to tax or tip after tax. And that becomes just a preference based on your experience, or maybe when you go out to a restaurant with your family, your parents may also have that conversation as to whether or not they're going to tip on the total bill, which will include tax, or if they are going to tip on what was purchased prior to tax. So we're going to figure this one out just in the sense of prior to the tax added. So my question is more so thinking about what is 18% of $24.50. So let me write that there for those of you who want to see that. What is 18% of $24.50? Remembering that that $24.50 is before tax. So now we can just set up our is over of percent over 100 proportion and solve pretty quickly. So I don't know my is. I know that I spent or will spent $24.50 at lunch. Will wants to leave an 18% tip. Cross multiply and divide. So when that happens, $24.50 times 18 gives us 441 is equal to 100x. Okay, you'll notice I've just, for the sake of time on the video, skipped that first step of writing out what I'm multiplying with the cross multiplication, but you guys are well aware of what we expect to have happen on your papers. And x is going to equal $4.41. So if we were to think about this in the idea of total, it seems as though lunch for Will and his friend was $24.50. The tax that we figured out on the previous slide was $1.96, and that tip was $4.41. So the total with tax and tip for Will and his friend would be $30.87. So of course, if they were going to split that, then we could just divide by 2. So as you do word problems that involve tax and tip or discount, it's going to be really important for you to read the question carefully and make sure that you answer the question that is being asked, not the one that you would like to answer, because it's the easiest way to do it. So hopefully you've taken the time to set up this problem to determine how much how much money is going to be added to the bill when it is an 8% restaurant tax on $38. So for those of you who have paused and played along at home, or played along in class if that's where we happen to be watching this, Peggy and Sue are going to owe $3.04 in tax. And if you also went ahead and did that the ladies want to leave a 20% tip prior to tax being added, that means that they're going to still use that $38 as their lunch, or was it dinner? Sorry, dinner bill. They're going to find out what is 20% of $38. And if you did that one, you should have gotten that they will leave $7.60 for a tip. So this next problem says Greg needs to buy a new dog bed for Luna. The dog bed is $75, but is on sale for 35% off. How much will Greg save on Luna's new dog bed? So instead of us adding a percentage to the amount that's already listed there, this says that there is a percent off. And that percent off means that it's on sale or it's going to be taken away from the original price of $75. So we still want to ask ourselves, what is 35% of $75? And when we get that answer, okay, we will know how much Greg is going to save on the new dog bed. So I'm going to start with saying is over of equals percent out of 100. I know that it's 35% off. That's the easy one to fill in on most of these. And I know that my of is 75. I want to know this value here. How much is Greg going to save? Same deal, cross multiply and divide. 75 times 35 equals 100 times x. 75 times 35 is 2,625 is equal to 100x. I can then divide both sides by 100 to isolate my variable of x, and that's going to leave me with x is equal to $26.25. This tells me that Greg is going to save $26.25 on that dog bed. So we could find out what he is going to pay, and that amount's going to be $75 subtract $26.25, and he will now pay $48.75 for the dog bed. It does pay to watch those sale prices. So this problem is very similar. Greg is now going to buy a dog bed for his other dog, Thunder. And the dog bed is $125 to start, but it's on sale for 40% off. How much will Greg save on Thunder's new dog bed? So we're basically answering the same question. What is 40% of $125? And if you completed this problem setting up your proportions, cross-multiplying and dividing, you will find that Greg is going to save $50. Which means that Greg is going to pay $125 subtract $50, giving him a new price of $75 for the dog bed for Thunder. Sometimes you are asked to find the percent change. This means that you have been given the calculated amount, which is our part or the is, and the actual amount is of. Once you've calculated the percent, you can subtract 100. If the difference is positive, you have a percent increase. But if the difference is negative, you will have a percent decrease. Sometimes it's easier to think about the new amount is and the old amount of. Then subtract 100 from your percent and determine if it was a percent increase or a percent decrease. Might as well try one. Last week, there were 1,500 cartons of milk sold at lunch. This week, there was a 15% increase in the number of cartons of milk sold. How many cartons of milk were sold this week? So, although we're not finding the percent increase, we need to find out the number of cartons that were sold this week. So let's think about this. This one makes most sense for us to think about this as being our new amount compared to the old amount. And I'm still going to think about that, not so much x, but let's say percent out of 100. And let's underline what we might know. So last week, that seems like old information, there were 1,500 cartons of milk sold. This week, there was a 15% increase of cartons of milk sold. How many cartons of milk were sold this week? This week is going to be my new. So let's set this up. X over 1,500 or 1,500 is equal to 15% out of 100. You might guess that we're going to cross multiply and then divide to get this answer. So I'm going to go ahead and say that 1,500 times 15. I'm going to write that down and see what we get. So why don't you try and do that same thing. We have 1,500 times 15 equals 100 times x. 1,500 times 15 is going to give me 22,500 equals 100x. Isolate my variable by dividing both sides by 100. X is going to equal 225. But now we've got to stop and ask ourselves a question. What does that 225 mean? And is it going to answer the question that was posed here? How many cartons of milk were sold this week? So we just answered that 225 is 15% of 1,500. This now, oh boy, this now is filled in here. But if I want to know how many milk cartons were sold this week, my new number actually needs to be 1,500 plus 225. And that will tell me that there were 1,725 or 1,725 milk cartons sold this week. Well, how did you do? What is the percent change in the number of slices of pizza sold? So I'm going to notice that right away, this week, my new week, that's not what I want to see. Let's try to highlight that. This week, the new week, there were more slices of pizza sold than last week. So that's going to tell me that I'm going to see a percent increase, okay, or an added percent. So, and when I figure this out, I'm going to write down that I have my new compared to my old. I have 900 compared to 675. I don't know my percent, but I know that's out of 100. And when I did that, I found out that I had 133 and 1/3% as my answer for x, or my unknown. And then I'm going to subtract 100% from that. And so I really find out that I have a 33 and 1/3% increase on the number of pieces or slices of pizza sold in this new week. So what I would like for you to do now is to go back and watch any part of the video that was a little bit too fast or you were unsure of as we were going through it, and make sure that you are understanding exactly what these percent applications mean as we move through what is required of us as 7th graders. And then I've posted some links in Edmodo that you are going to go to. One of them is Khan Academy. There's some more practice problems that I've completed on a Google form for you. And then I'm going to challenge you to write 3 problems of your own that involve tax tip and or discount. All right, remember that as you work through these problems, you're still required to have your work on white line paper, setting up your words, your known and your unknown proportions. Boys and girls, I hope that this video has been helpful to you, and I'm happy to help you during class and, of course, at lunch or after school.